My name is Fiona. I'm a professor of health policy in the Institute of Health Policy Management and Evaluation, and I direct a new center at the University of Toronto, called the Collaborative Centre for Climate, Health and Sustainable Care. And I just wanted I want to thank Stephen for collaboratively producing this seminar. As the Collaborative Centre, very much our agenda is to work with other centers of excellence, communities, with individuals and organizations to bring attention to the health system, of course, health equity issues arising from climate change, global change, and the overlapping social and structural issues that are and creating these linked challenges. So the Collaborative Centre is newly created as of November of 2023. We are deep in trying to clarify our strategic plan, so what we will accomplish and how we will work together for health science faculties, School of Health, Temporary Faculty of Medicine, Law School of Faculty of Nursing, and also the pharmacy and come together to produce the unity. And so I invite you all to connect with us to help us to do this work in partnership. But I'm really delighted to be able to introduce Marianne Touchie, who is an associate professor who's jointly appointed. I was teasing her that she represents 4 different engineering disciplines, but really she's civil and material engineering, one department, the other department, mechanical and industrial, because she was saying buildings really at the intersection of these critical engineering disciplines and sciences. So Marianne is the director of the Building Energy and Indoor Environment Lab, and her interdisciplinary program of research lies at the intersection of human occupants and their behaviour and the built environment, the building envelope, mechanical systems that create and structure those environments. So through research that explores those intersections, she wants to improve energy performance of buildings, she wants to improve indoor environmental quality, and she wants to improve human experience, health and well-being. So absolutely the perfect person to help us explore these critical challenges arising from climate change. Thank you so much.
I think our camera is on. Maybe we can get a thumbs up or somebody online if we can see. You can see. Wonderful. Okay, that's great. Okay, I'll speak a little bit louder. Is that okay? Yeah. Okay. Wonderful. Thank you so much for having me and for the invitation. I'm just really delighted to be here and to connect with this community, which I'm from. So really delighted to meet all of you, and I hope we'll have an opportunity. I hope this is the beginning of other conversations, which would be great. So today, a little bit of background for me. I was actually speaking part of this before, but my journey to getting here, and really this pathway all started with my PhD, where I was investigating the energy performance of multi-unit residential buildings. And I was just really worried about the energy use, but as part of my energy model development, I actually went in and monitored people's apartments, how hot they were in the middle of the summer, how cold they were in the winter, how they tried to cope with these extreme conditions. And so that really led to me when I had the opportunity to take on a faculty position. Can you still hear me? Great. So that really led me to think about this intersection, as Fiona mentioned, between, of course, reducing the environmental impact of our buildings. We all know we need to do that, but at the same time, how can we improve the lived experience for the residents? And so that's a little bit about what I wanted to talk to you about today. So I'm going to start off with what MURBs are all about. I'm a little MURB obsessed. We'll talk about some of the performance issues that we see now and some of the challenges that we're going to see in the future with climate change. And then I'm going to, because I really don't have time to talk to you, we're going to kind of condense this a little bit. I'm going to flash some technical solutions at you just to kind of get those going, and we can explore those later in the discussion. And just kind of build a case for a more holistic consideration where you could see how it's going to be. So what am I talking about when I'm talking about post-storm MURBs? How many people have seen buildings like this in and around the Toronto area? They are everywhere. We have over 2,000 of them just in the GTA alone. So these are really common building type. Thankfully, a lot of them were built and constructed in very similar ways with similar systems. So as we develop solutions to these buildings, they can be really broadly deployed across the So who lives there? I'll preface this, these statistics are actually from Toronto Community Housing, so they don't necessarily represent all of the post-war buildings, but a lot of these post-war buildings are serving social housing communities, as well as the private rental. So we do see a lot of priority communities in these buildings. Many of them are yet intended. Many of them have accessibility challenges. So these are communities that we need to be paying attention to when it comes to. So as I mentioned, these buildings have a lot of very similar design features, and so that then leads to a lot of very similar performance challenges that we have. And I'll step through these in a little bit more detail. But these are very high energy intensity. So when we think about retrofit opportunities, these are great buildings to target because there's a lot of opportunities to do better from an environmental performance perspective. While we're in there making changes to the building, we also have to deal with a lot of discomfort issues, thermal discomfort, factory discomfort, smells, and things like that, acoustic discomfort, and a number of other issues as well. So where some of this perspective came from was a large study that we did. I was actually working for the Atmospheric Fund at the time, but collaborating with my colleagues at the University of Toronto, and then as I joined as a faculty member, I came in sort of on the tail end of the study again with a different lens. And so TAP, the Atmospheric Fund, was partially funding some of these retrofits. And so we were really interested. These were 7 social housing buildings undergoing deep energy retrofits. They wanted to understand what was the impact on the residents of these changes. And so we came in and developed a monitoring program, monitored the surveyed them periodically to understand what their experience was like. And so we had low rise, mid rise, and high rise. And these results are all about 10 years old. So think about these thermal comfort responses, perhaps in the context of what we've been experiencing over the last week. But at this time, the vast majority, or the majority of residents were experiencing some sort of thermal discomfort. And you'll see, I don't to remember, but F and G are the high-rise buildings. It is very difficult to control where energy and air go in high-rise buildings, and so you tend to see these really, you tend to see a lot more discomfort issues in these larger, taller buildings. So F and G, you can see, 75 to 80% of the time we're uncomfortable in the summer. And in the winter, it's interesting. You've got some parts of the building that are overheating, and some parts of the building that are. And when we look at indoor temperatures, what I really want to kind of zoom in on is the amount of overheating that is happening. So it's not just during summertime, it spreads through the spring and fall as well. And one of the features of these buildings is they're very thermally massive. So the walls themselves are made up of concrete masonry units with brick finishes. So a lot of mass. When that mass heats up, it takes a long time to cool it. So if you open your windows at nighttime expecting to get some relief, you'll kind of see the black line is the outdoor air temperature profile, the 2 red lines are indoor air temperature profiles. You'll see that when that temperature dips at night, you see virtually no benefit during the daytime, or sorry, during the inside. So this is hugely problematic, especially when you have a multi-day extreme heat that this really goes up in these from an olfactory discomfort, what this suggests to us is air is not going where it should be. We're not getting enough outdoor air to occupy spaces to dilute contaminants. And we're getting cross-contamination, so we're getting contaminants moving between suites. So one person smokes, another person smells it. All of these homes are really interconnected. And so really widespread olfactory discomfort from various sources. This was a separate study, but we were really interested in also trying to understand acoustic comfort in long-term buildings. So these are places your walls are connected to 4 different families, above, below, and side to side. So there's a lot going on in these buildings. And I'll just note that on the scale here, green does not mean good. This is all kinds of annoyance. So from slightly annoyed all the way to extremely annoyed. So what you're seeing here is that, again, the vast majority of people are annoyed by both indoor and outdoor sources. And this can actually have a really big impact on people. It can affect their sleep. It can increase stress. It can prevent them from working or being able to study. So it's not just sort of mild annoyances. It can actually be huge. We went a little further to figure out how do people actually cope with this. And so what's interesting is a lot of their responses to acoustic comfort can actually make the situation worse, i.e. turning up the radio or TV to mask other people's noise, which creates problems for your neighbors. Or it can actually have a negative impact on building performance. So things like weather stripping your suite door, which in these buildings, and we won't get into all of the different systems right now, that's where your outdoor air is supposed to come from. So you're potentially shutting off your one source of ventilation air to deal with these issues. The other really big thing that we've seen in a lot of our post-occupancy evaluations is control. A lot of these larger buildings have central control. So one example in these post-war buildings, how many thermostats do you think for a post-war building? 2. Well done. So one for the north side and one for the south side, or the east side and one for the west side, and that is how the entire building is controlled. And so how do residents modulate their temperature? They open and close their window. And so you can see that there's these connections between comfort and energy, because if you're opening your window to reduce the overheating in your building, in your suite, you're actually wasting a lot of energy, which then drives higher energy. So frustrating for residents, but also has really impact. These are a number of quotes. Actually, I just pulled from a few post-occupancy evaluation that we just finished, which is a building in Hamilton. And it's kind of disheartening to see. This was a deep retrofit building, new technology, brand new windows, and because there was no consultation with residents on potentially trying to identify some of the challenges with these new technologies. They're having a lot of challenges. So in the context here, I'm not going to spend a lot of time on this. I think we all know where we're going. We've experienced a lot of everything last week. So we really need to start thinking about, okay, these buildings are not doing great now. So what are we going to do to better prepare these buildings for the future? So what we're going to start to see is increased heating loads. So the context there is, when we think about retrofits, people are often thinking about our kind of insulation, don't make it super airtight, add triple glazed windows. And my question is, do we really know that, or should we really start to be thinking about overheating? What are some of the measures that we can do to reduce overheating? Well, of course, reducing heating load. We'll still be a heating dominated climate for a while. But in the time I've been working on this space, we've already warmed 2 climates. So it's happening quickly. And I think we need to pay more attention, forget the things that we not totally forget, but let go of some of our past practices and think about what else we need to do. So just flashing at you, this is just a indication of the CWEC there is a standard weather file that we use to model our building. So when we're trying to understand the implications of a design change, we create a model of our building, we stick a weather file in there, and we kind of test run that building. And so we can see how much energy it's going to use, we can see what temperatures it's going to be in the space. But we use historical weather data. So one of the things that we need to start doing is integrating future weather. And so this was just one really quick example where we compare the weather data that we're using now to what we might be seeing in the 2040s. And you can see that our space cooling energy use is going to go way up. But on the right-hand side is what we call unmet cooling hours. So we design and size our heating and cooling systems based on what these energy models tell us. So if we are designing a system to meet that little tiny rectangle on the right-hand side under CWEC, we are vastly under designing the system to meet the needs of the 2040s. So what impact does this have on people? Well, in a lot of parts of our society, people have air conditioning. But when we look at sort of the lower end of the income scale, and when we kind of map that to who's living in these buildings, these tend to be communities with far less access to air conditioning. And this is problematic given some of the features that I just presented in these buildings. These buildings are different. The windows are restricted to 4-inch openings. They don't have any solar shading. There's a lot of things that are actually making these buildings worse in terms of the environment that they create for residents. Plus, there's no air conditioning. So I can flash all these numbers at you, but I just wanted to share, if you haven't seen this, this is about 60-year-old, but CBC did a really nice sort of investigative journalism piece on people's experience in these apartment buildings without air conditioning. And I found it really eye-opening. This is what we've been hearing from a lot of our residents that we work with studies. But some of the videos were really compelling. So if you haven't seen this before, I encourage you to take a look. But I mean, the numbers on the right really speak for themselves. There's a limit of 26 degrees that's been kind of floating around a bunch of jurisdictions. It's sort of a maximum allowable heat in apartment buildings. And you can see, sorry, in any residential space. And you can see, you know, in a typical hot system, 2 summers ago, you can see that, you know, over a multi-day event, even to that limit. And apologies, these pictures are from 2013. But there's other things that we need to consider here. Outdoor air quality is a big one. Less so in Toronto, more all over getting there last summer. I remember smoke for a week or so there. So we need to start thinking about other ways that we can protect. We don't have central filtration or things we so we need to think about that as well. And one big one that really worries me is power outages. And we saw that a little bit yesterday. But the backup capacity that a lot of these buildings have is pretty little. Emergency lights, maybe some elevators, maybe some pumps. But we're going to have a multi-day event. These buildings will be uninhabitable. So where does it go? What if you have accessibility issues and the elevator goes out? There's no water anywhere. There are a lot of issues here, and I think there's a kind of this looming challenge where I don't know where we're going to put hundreds of thousands of people. This talk is all about post-war towers, but the same could be said of all of the last condos that we have. So stepping back from this, I think one of the pieces we often talk about climate mitigation and adaptation as 2 separate pathways. But I think within buildings and probably in the other areas, we really need to think about these issues as being related. Because the way we design and operate buildings does have a direct impact on energy consumption, which influences our GHG emissions, which in turn influences climate change. And so by driving one down, we can actually positively impact the other. So when we're thinking about retrofit strategies, we really need to think about this through 2 lenses. So we want to obviously reduce our GHG emissions, so reduce that environmental impact, but we need to start making change. We can't just keep doing it. We have to think about what these buildings are experience. Major renewables in these buildings only have nothing to do. So this is our one shot to get it right. This is going to impact families for generations if we don't. And so when we talk about mitigation, we're talking about things like reducing energy consumption, electrification. A lot of these buildings, I'd say 80% of the carbon emissions from these buildings are because of the natural gas that's used for domestic hot water and for space heating. So getting away from the sources is critical. On the adaptation piece, we need to increase cooling capacity, even though that has a negative impact on our operational carbon. As I mentioned, I'm really nervous about this backup power piece. I need to be more thoughtful about that, and developing more robust ventilation strategies. And I don't have time to talk about all of our research today, but if folks are interested in that ventilation piece, we're doing a lot of work on that in but what I'd like to propose is a third problem as well. If we're investing millions and millions of dollars, like a major retrofit, a deep energy retrofit in Kingsbury Tower, I've seen costing between $15 and $20 million. This is an enormous investment. If we are investing this much money, we need to also take that opportunity to improve the experience of individuals. This is not all about reducing carbon. Also, let's make these buildings better. And there are a lot of solutions that can take off. So I'm going to put these roughly into a couple of big bins. So passive measures, what I mean by that is things that don't need energy. These are just changes that we can make to the enclosure that can reduce energy. Active measures, which are actually active systems, things like space heating and space cooling systems. And then when we think about the decarbonization side, this is really all about fuel switching. So getting away from those natural gas appliances into electric. So this one I'm going to go fairly quickly through. I don't want to overwhelm you with a bunch of different technical solutions, but I just want to show you there are some things that we can do that we're not doing. Every time I travel, I think my husband gets, you know, I can't take on pictures of exterior solar shading. I'm like, you're doing this. They're doing it so well, and it's in cold climates that have snow that have high winds. Like, this is possible, and I just don't know why we're not doing it here. And it doesn't have to be fixed. They have really great operational options as well, and it's particularly in buildings with balconies. I think that this can actually improve usable space too, because you now have a shaded outdoor space where you could shelter if necessary. The other one, so I'm not sure if you're aware, but we have window opening restrictions, which are at 4 inches. You can take it off, but you're supposed to take it off for like safety issues. But one really simple thing to do is actually just to remove the window opening up above the balustrade. So where you have a balcony, you can drop anything there if you wanted to. But you can really open up those windows and design those windows to more fully open if you move the opening level up. There are also windows that are being used in other countries. One example is this horizontal tilt window. The benefit of this is it creates a little bit of what's called stack effect that can actually drive air movement on a single orientation. One of the best things to do, and this is more of a design issue, is to have openings on opposite sides of the suite, or at least on 2 orientations. This is not very common, and frankly, there's not a lot of people that use this. So windows like this are one pathway of trying to promote a little bit more. So coming back to the overnight temperatures, solutions like this can get a little closer to maybe making those indoor conditions more habitable. We can get more of that cool outdoor air to circulate through the space. Really popular right now is overcladding and improving air tightness in buildings. This is actually the building that we've been working with for the last 2 years in Hamilton. We've been following the residents, and you know, great strategy for improving reducing your carbon emissions. But can also have, at least in the wintertime, can have really good impacts for thermal comfort. But I kind of want to flag this. This is not really necessarily a pathway that we absolutely should take. But more of an example, I wanted to say that people are using this pathway a lot, but this is incredibly material intensive. We're adding a lot of material which has carbon associated with it. And can potentially lead to overheating issues. Passive house, which is the standard that was regulating this particular retrofit. Great for space heating, really reduces space heating, but doesn't do a great job of contemplating overheating. And so we started to see that in this place. So one piece that I don't think we're talking enough about, and something that I've spent a lot of time in my group looking at, is what we call interzonal air leakage. So I mentioned before that all of these apartments, all these households are connected to one another through airflow paths. That has implications for pest transmission, sound transmission, and as we showed through some of the recent studies, energy use. So this is one retrofit, fairly low cost, fairly low energy, fairly big, and not that disruptive to do. That can actually tick a lot of boxes when it comes to comfort and energy. So, and little things like adding elevator vestibules. It sounds like a small thing, but elevators connect to these huge vertical shafts that really drive the stack effect. So you're getting a lot of uncontrolled air movement moving through these vertical shafts. And so one really effective way to achieve this with any operating residence is to seal off those vertical shafts so you kind of get each floor operating. This is a little, I've had conversations with a lot of building owners on this. This is not unachievable. It's just a little more challenging depending on the type of but essentially what I'd love to see is each suite actually treated as an entire building. What I would love to move towards is having in-suite ventilation through the form of a heat or energy recovery ventilator, really air sealing that suite. By tightening up that suite, you're effectively making this like an independent little house in the sky. So that person in that suite can do whatever they want. It's going to have very little impact on others. So that's kind of the direction to go. Also can potentially have energy benefits if we have demand-based heating, cooling, ventilation. So let's speed that up and that system shuts down. We can't do that with simple systems. We have to operate all the time. And then there's also that potentially protective effect of adding in speed filtration. I wanted to geek out on this a little bit. So this is some of our, I'll just flash this briefly. If this is something that interests you, you can chat about it later on. So this is some modeling work that we did to really demonstrate the energy impacts of interzonal air tightness. So on the y-axis, you basically represents the amount of cross-contamination you're getting between suites. And then the y-axis represents the space conditioning energy. So essentially what we want to do is move from the top right to the bottom left. As we make that move, we're reducing energies and reducing that interzonal transfer. And so we can do things like, move from a centralized system, which can get us part of the way there. But we can make some really big leaps by just tightening up key parts like the elevator doors and stairwell doors. And then when we kind of put those things together here, when we, make that centralized to decentralized move and really try to tighten up the suite, we can see improvements in both areas. So again, I think this is a strategy that we need to start making attention to. So on the active side of things, giving enough credit to fans. Fans can actually delay the time or delay kind of the onset of air conditioning, but the need to turn on the air conditioning. So if you can make do with fans as long as possible, you're actually avoiding a lot of that excessive cooling energy. And it also kind of helps you, and I'm going to stop mailing a little bit, but helps you physiologically adapt to those more extreme conditions rather than being exposed to the city all the time. And then when you have to be in conditions that are not like that, your body is not. The other piece too, and where I think we need to start paying more attention to the co-benefits of this. There's a lot of talk about air source heat pumps right now. I mentioned we need to electrify, we need to get off that natural gas. So one of those things we can do is go from natural gas appliances, boilers, and things like that to heat pumps. I think it makes a lot of sense just from a decarbonization perspective, but it also has the added benefit of adding cooling where it was before. So heat pumps are reversible; they can both heat and cool, and that is a huge benefit. And I think we need to absolutely make it there to build numbers. It might be a slight or additional cost. It's going to be more than simply replacing a boiler, but can have tons of benefits. Smart thermostats are another area that I think we need to start paying more attention to. They can not only decrease space conditioning loads, but they can help with all sorts of diagnostics, like figuring out on these buildings. One really interesting idea, and I think there's some researchers at the University of Waterloo who are working on this, is we can take advantage of the smart technology to help warn people when their indoor spaces are no longer safe. I mean, we have smartphones and smartwatches where we could absolutely do the same, but to embed that that sensing technology and that ability to warn people, you might want to go to a cooling center, or you might want to consider turning on it, or grab that fan and get rid of that fan. So we can use building control technologies to actually provide real-time feedback to residents to keep them safer. And then the last one, I just want to flash at you, and you kind of go like, what is it here? But this is an area that we've been spending a lot more time in. I've been thinking a lot about how residential spaces impact individual community development. How we can utilize these common area spaces to really promote a sense of well-being. And it's not just well-being for well-being's sake, it's also for safety's sake. If you know your neighbors and there's an extreme event, you're going to check it on them. When we think about the heat dome in 2021, a lot of those people died alone. Some of them had access to air conditioning and didn't use it, but I think there's, especially in multifamily buildings, this is really an opportunity to provide that level of safety, I think, but being able to check on one another. And it obviously just for people's so just to summarize, I really see this kind of multi-stage pathway, but they really, in my mind, they all need to go together. It's not one and the other. We need to reduce demand and increase our resilience at the same time using some of those active and passive measures that I shared with you. Thinking about electrified supply, really drive down that environmental and perhaps this opportunity to really improve the experience of residents, because in many of these buildings, but of course, retrofits are, has anybody gone through a deep energy retrofit in their own home? I did about 7 years ago, and I'm still traumatized by it. It's very, very disruptive. And so, what's that?
Stay.
Okay. So it's very disruptive to residents, and so I think we need to think very carefully about how deep we want to go. Everyone's go deep and go fast on these retrofits, but I think we potentially need a lighter touch in some of these buildings to get people safe quicker and to potentially reduce resident disruption there. And thinking about prefabricated solutions, what are things that are kind of plug and play that can do relatively little disruption. The other piece that I'm thinking a lot about is the impact on the building. So if you are in a private rental building and you're investing tens of millions of dollars in retrofit, you can apply for guideline increases and increase those rents to recoup those costs. And so this is a particular sector that I think needs more support from government to kind of roll this out more broadly. Because you're walking this fine line, right? If you need to improve the performance of these buildings, but you don't want to do so to the point where you're eliminating affordable housing options. So you need to be really careful about that. And that also comes down to the particular retrofit design decision. And I think this kind of links to the idea of we currently have really inequitable protections associated with climate change. We have huge swaths of the city that have access to air conditioning whenever they want. We have other parts of the city that have no way of accessing that and don't even necessarily have ready access to cooling centers, which we do. So I think this is an opportunity to kind of move ahead on all of these. And so what I've been, the idea that I've been kind of pushing to folks is what I'm calling sort of multi-solid retrofits. Like, of course, we need to reduce carbon. I think we all recognize that. As I mentioned, we really need to improve our resilience in these buildings to extreme events. A lot of these buildings are in a state of disrepair. I don't have time to go into that today, but this is also, again, this is only happening once every couple decades. This is an opportunity to kind of bring everything back up to reasonable level of maintenance. Improving livability and community by creating more quality community spaces, frankly. If you're going in there with these major retrofits, one of the buildings in Hamilton introduced a new community kitchen, community garden, which why not? You're reconfiguring everything anyway, so make sure you include those spaces. And there are other issues with that. I mentioned this improving health comfort, obviously, and equitable access to protections against climate change, and making sure that we're improving housing affordability. Right now, we tend to focus on petals 1, maybe 2, maybe 3 if you're lucky. But I think we need to develop tools. We need to reach out to the design community consultants who put these retrofits together to start thinking. You're not necessarily going to be able to tick all of these boxes, but you should at least be considering anything you're investing really needs to address multiple issues. Funding is a very challenging piece. Like how, and there's been a lot of great work. This is from, I think, we started to kind of piece together what does this look like in the private sector? What is this is not my area, so I'm not going to really go further than that, but it's really this balance. You can increase the rent a little bit, not too much to significantly affect affordability. You're going to see operational savings as you reduce that energy use. And then you kind of got to, there's going to be a gap somewhere. So you've got to fill that gap with various, The other piece I'm thinking Fiona about is at the beginning. This is something that we're trying to put a little more effort into at this point is we always talk about carbon and energy and the costs associated with that, but it's also cheap in Canada. It's never so we really need to start thinking about social support. This is where your community comes in because I'm an engineer. I know nothing about this. I'm trying to learn, but I really want to work on monetizing this and making it part of the retrofit conversation. It's really critical. I think these changes have really widespread impact. And just to conclude, I've kind of mentioned this through the presentation, but I think our post-war towers have absolutely got to be the priority here. These are the communities that are most at risk of seeing the negative impacts of climate change, experiencing those negative impacts. But again, it also has these opportunities. We can address energy poverty, we can address health. We can do so many things with these retrofit dollars. I believe we absolutely need to start here. And by really investing in this community, the benefits to the private sector, you develop skills in the industry, you develop these practitioners who think how to do this well, and can then make this more work. So this is my vision, this is what I would love to see. And I'm wrapping up because I have a little bit better. So yeah, just to conclude, I think every dollar really needs to do a lot more than what we're doing right now. We've got to preserve affordability and reduce disruption. I just wanted to point to these quickly. ERA, which is a local architect, has done a ton of work in this space. The lead guy's master's thesis was actually what inspired my PhD thesis. It's the Tower Renewal Initiative. I'm sure many of you have heard this. And just if you want to read something over there.
Thank you so much. So now we have time for some questions.
Several years ago, I brought forth my brilliant concept, electrifying the world. And I sent it to Haviland, where my buddy that I scuba dived with is superintendent. And what it was is to electrify the airplane NASA industry in the world. It took 4 years after I implemented that idea, and they built the first all-electric jumbo jet, 380 passenger seat jumbo jet in Norway. Now, right now as we speak, 70 airplane companies have turned totally to electric, and thus revolutionize the NASA industry. So how do we, ideas become ideology? How do we take broad subjects like climate change and influence it in our daily encounters and make housing more affordable and better? The cosmos of gender sensitivity. E equals MC squared. My mom's formula for pablum and biscuits. Climate change is your disaster waiting to happen. The liturgy of the ecosystem. 60% of all food produced in the world, in the global village, is wasted.
That's a simple question. I'm trying to paraphrase for the online audience. How do we take this from an idea to kind of making this status quo in like
It
how
could
do
be
we,
status quo.
yeah.
Status quo is a union word.
Right. So how do we adopt this and
Make transformative change.
Transformative change. Thank you. Then concise way of looking at it. Yeah, I think it's tricky, and I don't quite know the answer to that. We've had so many pilot projects. Frankly, I don't think that we've learned enough from. I think we just need to stop with the pilots and just start doing it. But I would like to say I think we need to require post-occupancy evaluations. They don't need to be as heavy touch as what we do. Like we do surveys, we do interviews, we do tone of voice, we do monitoring. But I think there needs to be some requirement to show that building performance is actually being achieved, not just from an energy and carbon perspective, but what are they? You can use carbon stats to do this. Like, tell me how hot the speeds are in a.
I mean, I think possibly people don't know about that gap. To people, because that's their performance gap.
Oh, that's a great, okay, yes, so people build stuff all the time, nobody ever checks performance, essentially what's happening in our industry. And so, it happens both in new construction and in retrofits. So my whole space is all about going in and checking, but I'm a researcher and we just don't do that in industry. And so there's very little accountability. There's also very little reflective practice. So, you know, an architect or an engineer will put something out into the world and through no fault of their own, never get any feedback on whether or not that solution worked. Unless there's right after occupancy. But so I think we need to be more thoughtful and more deliberate about collecting that information, ideally in a practical, repeatable way. And then we can show once we've get out of this pilot phase and we start doing it, we can show en masse which solutions are working and which aren't. So I don't know if
But this is a great talk, and I think I could talk a very long time today, but there's a couple of things. I think the city of Toronto wants, like I live now in Toronto, but a lot of probably mentioned for this building exists in the high rises, right? So this, I saw the city of Toronto wants to make all the high buildings by 2050 or 2040 or something. There is a mandate for that. The other thing is also, I think Toronto Hydro is doing this cheap water project everything up here. So I said, okay, I did by the way, can we not attach our the air conditioning to this system? No, it's not possible because it's only for this. So there are good ideas out, but it's very difficult to get connected to that. Is there any ideas how to the accessibility to already good ideas?
okay, so the question just for folks online was, City of Toronto is requiring all of these larger buildings to be retrofitted by 2050. There's a lot of neat ideas out there, like deep lake water cooling. There seems to be a barrier to connect some of those buildings to this, and how do we get over those barriers? Some question. I'm not necessarily. I don't know a lot about that deep lake water cooling piece and what's restricting that connection.
I don't think they have the capacity to cool. Like I know some
Oh,
of the hospitals
okay.
connected.
And there are already.
And they're not with the max steps, but so there's more capacity needed for that. So some of these are.
But I think there's a larger challenge looming, and we were talking about this before the talk, is electrical capacity in these buildings. And so what's restricting a lot of the choices at the retrofit stage is we just can't afford to get off our natural gas domestic hot water boilers because we don't have the capacity at the site level. And so that's really like, I guess if you're on a hydro IESO issue. And interestingly, and I don't know if this is true, but I think if something fails on site, then the utility has to pay for it. But if you request additional capacity, then you have to pay for it. So it's just a huge barrier to entry. And so I don't know what the answer is here. I think it's some combination of I think doing a better job on the reducing demand side of things. I don't think we're paying enough attention to the passive measures that I showed. So I think there's probably opportunity to get further with our existing electric capacity that we're probably not doing, but it's going to be a partnership. And all of these folks have to work together, and this is what I think makes this such a tricky problem. Toronto District 2030 or District 2030 Toronto, whatever they're called, have done a lot of work on trying to convene these groups and bring them together and identify these barriers. So if this is a space that you're interested in, I would really encourage you to read some of their reports. They thought through a lot of these challenges.
So my one comment was your comment about going in afterwards and asking residents to do the work. I need to take back one step and say, like, when you're planning to do what you're doing, are you consulting with users before you're, and then follow up with them to see how well you did.
Just for those online, this comment was, rather than just asking folks after the fact what worked and what didn't, why not engage them in the design process? Talk yesterday or last week was all about resident-centric retrofits and why we need to be part of this discussion earlier, because when you look at all of the challenges that we've seen, these are, I think a lot of these were foreseeable. If you had consulted with, show them a mock-up, let them play with it, see if they can operate these various components. You find out pretty quickly that it was not going to be an appropriate solution.
So first, you're not the only one who's taking pictures of buildings on vacation. Like, it's ridiculous for like photographing windows and like rolling shutters. Very cool design features. I'm wondering, there's this push now for minimum temperature bylaw. So and also a little bit wrong. I'm wondering if you talk about maybe the experience of perspective research And whether if there were going to be a bylaw, where would the set?
Yeah, that 26 is based on. Actually, I don't know which one these were. Yeah. At the University of Ottawa, but I believe there is some fairly good basis for the 26 degree. But again, it's kind of outside my area. I think there's going to be a lot of challenges with implementing this on a broad scale. The electrical capacity, we just don't have the resources in a lot of these buildings to fully cool every single one. I think this will be a huge challenge, and this is where I'll say it again, we really need to take advantage of some of those upstream steps like solar shading, fans, and the big piece is resident education. And this is not a one and done. It's that this is where I really want to see us use smart technologies to provide guidance in the moment. Like, okay, maybe you want to turn off the fan, maybe you should open the window overnight. Like, provide those suggestions to help people get to AC as like a last resort. I think that's how we need to start thinking about it, rather than, oh, I don't look. Sorry, that doesn't really answer your question, but I know why it's needed from a health perspective. I think it's going to be incredibly challenging to actually do.
A decade or so, the gas was the way to go because of the cost of electricity. And now it's more affordable, but a lot of the buildings are still gas powered because of the cost of heating and cooling. So my question is that not probably the post-war buildings, but other buildings, they have forced air. And so the hallways are cold if they are, but even if you open your window, there's no cold air coming in because it's a forced air. So the air comes from the hallway and pushes into the windows. Even if you open your window, you don't get any cold air. So can you comment on that? And also another question is, going forward, all these glass buildings, glass loses so much heat. So that's not a way to go for these concrete blocks into glass buildings, because that's a horrible heat loss through the windows. So if you could comment on that.
Totally. So just to paraphrase for those online, sometimes it's difficult to actually get any outdoor air through your window just because of the pressure balances of the building. I could talk to you all day about that. We've done so many projects about understanding that interzonal airflow. It's tough. I think to be completely honest, I think a lot of the systems that we've been working with over time they're like commercial ideas that have been dropped into large residential buildings, and they do not work. They've never worked. Stack effect has always been there. It's they're just not fit for purpose the way that these systems are designed. So I'm happy to chat with you about alternatives and what you can do in terms of retrofit. Okay, but I think there's a lot of options. And the other comment was on the glass towers, and that's another huge looming problem that I think about a lot. It makes me really sad as I drive through downtown Toronto. All of these buildings need to be retrofitted basically from the way they're put up. We should have never allowed that kind of enclosure. It's just completely unsustainable. It's not comfortable. Power outages is uninhabitable. You're using way more energy than you should. So again, just inappropriate design.
With that, I think we're going to have to call it to a close. And thank you, Marianne, so very much for a wonderful talk, proving, of course, that we need to continue this conversation. We need the engineering, we need the public health, we need the understanding of geography and policy and politics and economics and all of this, because these are solutions that we're going to use to solve. Thank you so much, everybody.